Hello, I'm Jaideep Sen, and I'm going to present our paper entitled Modified Word Saliency Based Adversarial Attack on Text Classification Models. And, our paper ID is 163, and this is a joint work done by ex-students, Hedvi Waghela and Sneha Rakshit. They are professional data scientists now. We come from Praxis Business School, Kolkata. So before I start the presentation, I first point out the three major objectives of our work. We introduce a novel adversarial text attack method. Adversarial text attacks are attacks on text classification and NLP systems. What they do is they subtly change some words in the original text. The changes are very subtle, changes are very minor, and is not easily perceptible to the eyes of human, but they are done in such a way that the classification model goes in a wrong mode, and misclassification happens. So there are it's a very hot area of research, and we have developed one highly effective method of adversarial text attack. So increasing evasion efficiency, of course, is the goal for any adversarial text attack. That is one of our objectives of the current scheme. And we show that demonstrate the effectiveness of our scheme through extensive evaluation. Now, the contributions are three. Design of MWSAA. This is the name is Modified Word Saliency Based Adversarial Attack. We'll discuss about that method. So this is a novel scheme, and we have a new method of estimation of word saliency. Word saliency refers to importance of word in classifying a particular sentence or particular text. So evaluation of saliency of words is a very critical thing, and we have developed a new method of doing that. And of course, extensive evaluation, comparing the current method with an existing very well-known text classification adversarial attack called PWWS, probability weighted word saliency method of adversarial text attack. We have compared the performance and shown that our method is superior in almost all the metrics that we have considered for evaluation. So the outline of the talk goes like this: related work, methodology, implementation, dataset and language model, performance results, analysis of the results, conclusion, and the references. So the adversarial text attack is a very hot topic of research. Extensive work has been done and is being done at this current point of time. We have just pointed out some of them: Boucher et al., X et al., Zhou et al., Zhang et al., and Zin et al. So all of their basic objective is making the attack successful over large data set, over large language models, as well as making the attack more effective in terms of success rate. Word manipulation should be kept at a minimum, and the attack success is to be demonstrated with high level of simulation and experimentation. So the methodology is like this. You take the original text. We take the original text, compute the saliency scores. That's a saliency scores of words are basically gradients. So each of the words have got a gradient. So the word with the highest gradient, of course, has got the highest saliency. Word with the lowest gradient has got the lowest saliency. Now, word with the highest gradient actually is the most critical word in a sentence. If we change that by any other word, even by its synonym, the gradient will change, and whether that change in gradient will affect the classification, that is the objective. Now, original PWWS, the method which we have enhanced, basically computed the word saliency, computed the probability of their occurrence, and computed then a composite score. That composite score actually is used for identifying the most critical words, changed them with synonym or antonym, and then made the attack. Now, the problem with that method is that the word changes were too abrupt, because it is only the saliency that was taken into account. So the adversarial text and the original text mismatched in terms of their similarities. So if somebody has a very close look, somebody will be able to identify something wrong has happened. So that was our motivation, how to make the adversarial text look very similar to the original text. So we did not only compute the raw saliency score. What we did is that after the saliency scores are computed, we pass them through BART embedding blocks so that we can catch the context, because BART embedding blocks have the ability to identify the context in which that word has been used. So the context identification allows us to get a better idea about the usage of that word and whether that word change will be having an effect on the classification. And after that, we also have a cosine similarity computation based on the adversarial text and the original text, and only those modifications which yielded a very high similarity between the adversarial text and the original text were actually considered for replacement. So there are multiple, enhancement. Raw saliency score was passed through BART embedding block to catch the context, and then cosine similarity computation happened between the original and the partum text. Thereby, we get a refined list of words. Those words are now again went through saliency computation. So the saliency values now get changed. So the adjustment got made. So that final saliency list actually is now randomly chosen for substitution. And the substitutions are made in the similar way using the synonym or antonym from the Wordsmith's dictionary. And the substitution is done in order to make the text attack. So I'm not reading out from the text of the methodology. The implementation of PWWS is already available in public. What we did in our implementation of MWSSA, we took the help of text attack and open attack libraries, tweak their functions, because the BART embedding block has to be brought in, similarity scores have to be computed. So there was extensive Python programming involved, because there are different data sets, there are different language models which need to be integrated, which we'll see in the evaluation. And all these were a very time-consuming execution. So we used Google Colab T4 GPU framework for computation. So there are three pre-trained language models which are used: BART, Alberta, and Roberta. And there are three data sets: IMDb, AG News, and SST. And 7 combinations of the language model and the data sets are used in evaluation following PWWS. So we first did this experiment, randomly chosen 200 test samples from the data sets and computed how effective the attack is in terms of launching a success, in terms of getting the attack successful. And these are the successful instances. These are the attack rates, successful attack rates. We found Roberta on IMDb is found to be the most vulnerable because it has a maximum attack success rate for our model. And Albert on IMDb is found to be the most robust because it yielded the lowest success rate. Then we had 2 more evaluation. One is execution time, and one is the average number of queries the model needed to make on the model data set in order to make the attack successful. So there was a threshold level 150. Beyond that, it is not allowed. As per the standard of PWWS, we followed the same, and we found that none of the cases we needed to exceed that threshold. However, the minimum average execution time was required for Roberta on IMDb, and minimum average number of queries was required for Roberta on AG News. So for Roberta, the attack seems to be more effective compared to Albert and BART. Okay, These are the visual implementation. So, but one more thing I'd like to say that these, 200 test samples where 15 of them were chosen, right? So it is not just 200 samples chosen and the attack rates depicted. We had 15 200 samples and average figures have been reported. So this is the graphical evaluation. Now we want to go for one more evaluation to make the attack, story even more successful. So instead of the mask language model like BART, Albert, and Roberta, we also use word CNN, bidirectional LSTM, and CARE CNN following PWWS, and found that how MWSA work with respect to PWWS. We found that every case for all situations, what CNN IMDb, bidirectional LSTM IMDb, CARE CNN AG News, what CNN AG News, all the cases, MWWS has been more severe by reducing the accuracy of the classification model to much more extent than PWWS. Thereby, it is clearly understood that MWSA is a more effective method. And another thing you can see here, the original accuracy rate or the original accuracy of the model was very high, 86, 80, and they were brought down to 4.8, 1.90. That shows how severe the attacks are in even the PWWS, but MWSA is even more severe. And one more interesting thing to look at, that AG News is more robust than IMDb because it is a 4-class classification model. So attack found it more difficult to actually launch on it. And so this is about the accuracy. This is now the word replacement rate. As you know that less the word replacement rate, the better is the model, the attack scheme, because it needed to have less number of word to change. Here also MWSA wins over PWWS over all the cases, both the IMDb on word CNN bidirectional LSTM and CARE CNN and word CNN for EG News. So this is the result. You can see that the green tower basically is for the accuracy without attack, and the blue tower is basically accuracy without the attack. Green is for the MWSA and the red is for PWWS. So you can see the for classification accuracy, MWSA is yielding the lowest value, as well as for word success rate, the red tower are smaller. That means the MWSA requires less word to be substituted. So some of the adversarial text for certain situations, Roberta LM IMDb dataset, the green words are actually the original word. The red words are the adversarial text attack word, right? So previously, this particular sentence had a positive sentiment with a confidence 99. After attack, it is a negative sentiment with confidence 84. Similarly, for one example shown for Albert LM with AG News dataset, and one example for BART LM with SST dataset. So in the conclusion, we had proposed one word saliency based modified approach, MWSA. Extensive evaluation has been shown with the efficacy and effectiveness. And in future, want to go for reinforcement learning based schemes for optimizing the design of it. So these are the references, and thanks for your time. I am open for your questions.